From this video we shall learn what is an forward difference operator delta, what is an forward difference table, and how to construct forward difference table. Like the video, subscribe to the channel, share this video link with your friends, gain the knowledge and rule the world. Forward difference operator, it is represented by the symbol delta. The forward difference operator delta is defined by delta f of x is equal to f of x plus h minus f of x. Delta f of x is equal to f of x plus h minus f of x, where h is called constant interval of difference. Where h is called constant interval of difference. Therefore, we can write delta f of a is equal to f of a plus h minus f of a. Similarly, delta f of a plus h is equal to f of a plus 2h minus f of a plus h. How we get this one? Just observe the previous one. It has been incremented by h. So similarly, here also in place of f of a plus h, we need to write as f of a plus h plus h. h plus h will be 2h. Therefore, it is f of a plus 2h minus f of a plus h. That is replacing the value of a by a plus h. So f of a. Right. In that one we are done delta f of a plus h. So f of a plus h will be f of a plus h plus h. So it will be f of a plus 2h minus f of a. So the f of a will be f of a plus h. Similarly, delta f of a plus 2h is equal to f of a plus 2h plus h will be f of a plus 3h minus f of a will be f of a plus 2h, etc. and so on. Like that you can write for any forward difference operator delta, and the delta is defined by delta f of x is equal to f of x plus h minus f of x. It is called as a forward difference operator. The important points with respect to forward difference operator delta are: the first one is the values of x are called arguments and y are called entries. The values of x are called arguments and y are called entries. Second point, delta into f of x plus or minus g of x will be equal to delta f of x plus or minus delta g of x. It means when a delta has been applied to two functions, that can be written as delta of one function with the delta of another function. That is delta f of x plus or minus g of x is equal to delta f of x plus or minus delta g of x. The next one, delta c into f of x is equal to c into delta f of x, where c is a constant. Delta c into f of x is equal to c into delta f of x, where c is a constant. That is, the delta operator cannot be applied for constant. For that purpose, the constant has to be taken outside, and delta operator has to be applied for a function f of x, because the delta operator with respect to a constant will be 0. The note next, delta c is equal to 0. As I told, the forward difference operator with respect to constant will be 0. Delta c is equal to 0. So these are the important points which you need to remember while solving the programs or problems with respect to forward difference operator. forward difference table, the difference can be represented in the form of a table called forward difference table. The difference can be represented in the form of a table, and that is called as a forward difference table. Now we shall see how to construct such a forward difference table. Now we shall construct the forward difference table. First, draw a table. In that table, the row heading should be the first column of the row heading, values of x, second column of the row heading, values of y, then third column, first difference delta, the next column, second difference delta square, the next column, third difference delta cube, the next column, fourth difference delta to the power 4. Next, the values of x. The first value will be x0. The next value of x is x1. So while writing x1, you can observe there is a one row gap between x0 and x1. The next, writing the value of x2, and there should be a one row gap between x1 and x2. Similarly, the next value x3 dot 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 etc. The last one is xn. The next, values of y. So the values of y is nothing but the corresponding values which we get when we substitute the value of x0 in a given equation f of x, and that is nothing but y is equal to f of x. In that one, when we substitute the value of x, we get the corresponding value, and those are called as in values of y. So for x0, the value of y will be y0. You need to write in the same row in the next column. The next one y1, same row, next column. The first one is y0 and second one is y1. The next one y2, y3, etc. The last one is yn. Now you need to calculate the first difference delta. The first difference delta will be delta y0 is equal to y1 minus y0. And observe where we need to write the delta y0. Delta y0 has to be written in the next column, but in between the rows of y1 and y0. It means to know from where we get delta y0. So delta y0 is y1 minus y0. For that purpose, in the middle of y1 and y0, in the next column you need to write. The next one, delta y1 will be what? y2 minus y1. So that you need to write in the next column in between the rows of y2 and y1 as delta y1 is equal to y2 minus y1. And next one, delta y2 is equal to y3 minus y2. And you can observe it has been written in the middle of y3 and y2 row, but in the next column, that is in the column of a first difference. Similarly, we can write for delta y3, delta y4, delta y5, etc. And the last one will be delta yn is equal to yn minus yn minus 1. Yn minus 1. And next column, that is a delta square, second difference. So delta square y0 is equal to delta square y0 is equal to delta y1 minus delta y0. Delta square y0 is equal to delta y1 minus delta y0. That is the second difference will be differences of the first difference. So have written the delta square y0 value in the middle of delta y1 and delta y0 rows in the next column. Delta y1 and delta y0 are present in the first column, whereas delta square y0 is present in the next column. In that column, in between the rows of delta y1 and delta y0, we need to write delta square y0. The next value, delta square y1. is equal to delta y2 minus delta y1, and you can observe the place where delta square y1 has been written in the rows middle of delta y2 and y1, but in the next column. The next, similarly we can write delta square y2 is equal to delta y3 minus delta y2, and the last one will be delta square yn is equal to delta yn minus delta yn minus 1. Then next, moving on to the third difference. The third difference will be delta q, that is a delta q y0 is equal to delta square y1 minus delta square y0. Since in this one the space is less, that delta square y0 has came to the next column. Alright, so while writing in the book, write it carefully. Delta cube y0 is equal to delta square y1 minus delta square y0 should come in the next column, that is in the column of a delta cube next to the delta square column in between the rows of delta square y1 and delta square y0. And next, delta cube y1 should be written in between the rows of delta square y2 and delta square y1 in the delta cube column. So it can be written as delta cube y1 is equal to delta square y1 minus delta square y1. Delta cube y1 is equal to delta square y2 minus delta square y1. Similarly, you can write for the next delta cube y2, delta cube y3, etc. Right. The next fourth difference. The fourth difference will be delta to the power 4 y0 is equal to delta cube y1 minus delta cube y0, and it should be written in the delta to the power 4th column in between the rows of delta cube y0 and delta cube y1. So like that you can write for n number of differences. In this way you need to construct a forward difference table, and this one you will understand in a better way when we solve the problem of constructing a forward difference table. Like the video, subscribe to the channel, share this video link with your friends, gain the knowledge and rule the world.